Question 4.1.1, we have to evaluate the integral of e to the power x plus e to the power minus x all raised to exponent 1 over 4 all multiplied by e to the power x minus e to the power minus x dx. We can immediately see that if we were to differentiate this part of the integral without the exponent, we get that part of the integral, so we can set our u as e to the power x plus e to the power minus x, differentiating u with respect to x. Differentiating e to the power x gives us e to the power x. Differentiating e to the power minus x gives us minus e to the power minus x. And from here, let's multiply both sides by dx. The dx cancels that, so our du will be equals to e to the power x minus e to the power minus x dx. And we can see that this is just the same as that, so in the place of that we can substitute our du, and we already said that we will substitute u in the place of e to the power x plus e to the power minus x, but let's include the exponent, integrating u to the power 1 over 4 but our integral is not in the form of u, it's in the form of x. So in the place of u, let's substitute back e to the power x plus e to the power minus x, and that becomes our final answer. 4.1.2, we have to determine the integral of 1 over x multiplied by 1 plus 2 ln x dx. And you can immediately see that if we are to differentiate what's inside the brackets, we get what's outside of our brackets partially. So we can set our u is equals to 1 plus 2 ln x, and differentiating u with respect to x. Differentiating 1 gives us 0. Differentiating 2 ln x gives us 2 over x. We can multiply both sides by dx. Our du will be equals to 2 over x dx, and multiplying both sides by 1 over 2 . And if we were to rearrange our integral, we can see that this that we have here is exactly that which we have there. So we can substitute that by that, and we already said that we will substitute u for 1 plus 2 ln x. We can take out the 1 over 2 out of the integral. Integrating 1 over u gives us ln u, and we know that our integral is not in the form of u, it's in the form of x. So in the place of u, let's substitute back 1 plus 2 ln x, and this becomes our final answer. 4.1.3, we have to determine the integral of 2x cubed plus 2x plus 7x squared plus 9 all divided by 2x plus 3, and we have to use long division to determine this integral, where 2x cubed plus, let's rewrite that in standard form and not as you're given, plus 7x squared plus 2x plus 9 will be long divided by 2x plus 3. 2x cubed divided by 2x is equals to x squared, and x squared multiplied by 2x is equals to 2x cubed. X squared multiplied by 3 is equals to 3x squared. 2x cubed minus 2x cubed is equals to 0. 7x squared minus 3x squared is equals to positive 4x squared. We bringing down the 2x. 4x squared divided by 2x is equals to 2x, and 2x multiplied by 2x is equals to 4x squared. 2x multiplied by 3 is equals to positive 6x. 4x squared minus 4x squared is equals to 0. 2x minus 6x is equals to negative 4x, and we bring down the positive 9. Negative 4x divided by 2x is equals to negative 2. Negative 2 multiplied by 2x is equals to negative 4x. Negative 2 multiplied by negative 2 multiplied by 3 is equals to negative 6. Negative 4x minus 4x is equals to 0. 9 minus 6 is equals to positive 15, and we stop here because the 15 is not paired with any x. So from here we take the 15 and we divide it by that, 2x plus 3. So we are saying that 2x cubed plus 2x plus 7x squared plus 9 over 2x plus 3. We are saying that this is equals to x squared plus 2x minus 2 plus 15 divided by 2x plus 3. So the integral of this is just the same as the integral of that. And if you want to check your steps, whether you didn't make any mistake with your steps, you can take any number and substitute it this side, and take that very same number and substitute it that side. You should be able to get the same number. Differentiating x squared, we get x cubed over 3, and differentiating 2x, we get 2x squared over 2, and differentiating negative 2, we get negative 2x, and differentiating 15 divided by 2x plus 3, we get 15 ln of 2x plus 3, and because of the chain rule, we have to divide by the coefficient of the x, which is 2, because if we were to differentiate these, because of the chain rule, we are going to also differentiate the 2x. So this becomes our final answer. 4.9.4, we have to evaluate the integral of e to the power x multiplied by the square root of 1 minus e to the power 2x dx. And to evaluate this integral, let's first rewrite our integral as 1 minus e to the power x multiplied by e to the power x multiplied by that e to the power x dx, and we let our u equal e to the power x. Differentiating u with respect to x, differentiating e to the power x gives us e to the power x, and from here let's multiply both sides by dx. That dx will cancel that dx, so du will be equals to e to the power x dx, and we already have e to the power x dx there. So in the place of that e to the power x, let's substitute du, and in the place of e to the power x, we said we'll substitute u, but we have 2e to the power x u multiplied by u is equals to u squared du, and we use our formula sheet to determine this integral. On our formula sheet, we have the integral of a squared minus x squared dx, and we are told that it's equals to a squared over 2 cosine of x over a plus c. In our case, we can rewrite our integral as 1 squared minus u squared multiplied by du, where our a is equals to 1. So 1 squared is equals to 1 over 2 arcsine of x, in our case it's u, over a, our a is 1, plus c our integral is not in the form of u, it's in the form of x. So let's substitute e to the power x in the place of u, and this becomes our final answer. Question 4.2, the instruction was that we use partial fractions to determine this integral. When we multiply both sides of the equation by x plus 3 squared, from here, that x plus 3 squared will cancel that x plus 3 squared, and we'll be left with 9x plus 25 on the left side of our equation, and we distribute the x plus 3 squared inside our parentheses. That x plus 3 squared will cancel that x plus 3 squared, and one of the x plus 3 squared will be cancelled by that x plus 3 squared in the numerator, in the denominator. We have two unknowns, a and b, so we let x equal any two numbers. But if we are strategic, we will choose x to be equals to -3, because if we were to substitute the -3, -3 plus 3 is equals to 0, and 0 multiplied by that a is 0. So our b will be equals to -27 plus 25, and -27 plus 25 is equals to -2. So our b is equals to 2, is equals to -2. We choose 0. We can choose any other number, but let's choose 0 because 9 times 0 is equals to 0, and we'll be left with 25. 0 plus 3 is equals to 3. We said that b is equals to -2. We take the -2 to the right, it changes sign, and it's gonna plus with that 25, we get 27. Dividing both sides by a, we get that a is equals to 27 over 3, which is equals to 9. So our integral a over x plus 3, our a is 9. B is equals to -2, so -2 over x plus 3 squared. Integrating 9 over x plus 3, we get 9 ln of x plus 3. And if it's not quite obvious for us to determine, then we use u is equals to x plus 3, differentiating u with respect to x. Differentiating x gives us 1, differentiating 3 gives us 0. So du is equals to dx, and we get that, okay, we We take the 2 out of the integral because it's a constant. We get 1 over, we said that x plus 3 is equals to u, but the x plus 3 is squared, so we have u squared. And we also said that dx is equals to du. We can rewrite the 1 over u squared as u to the power negative 2 du. Let's try to integrate the u aside. So integrating u to the power negative 2 gives us u to the power negative 1 divided by negative 1, and negative 2 divided by that negative 1, it will be equals to positive 2 to the power negative u, and we can rewrite this as 2 to the 2 divided by u, and we know that our u is equals to x plus 3. So let's substitute this